I would like to prove in a different way to you that the cast diagram works well, and this will help you with your understanding of the diagram. So let's draw a triangle in the first quadrant, and we say this is angle theta, and we take a well-known triangle with known dimensions. We say the radius is 5 units, that's 4 units, and this is 3 units. So in the first quadrant, if we would write down sine theta, we know sine is opposite of hypotenuse, so it would be 3 over 5. Cos would be adjacent of hypotenuse, so it's 4 over 5. And tan theta is opposite over adjacent, so it's 3 over 4. Can you see that all of those, if we refer to it as coordinates, all of them will be positive? So in that way, all the values for this triangle will be positive in the first quadrant. Now, let's draw a second triangle. In the second quadrant, and you will notice now the radius stays the same, it has to stay constant, but coordinates wise, can you see that the y value will remain the same, and the y value in this case is 3 units, so this will remain 3 units, but the x value has to become -4 because of its reflection around the y-axis. So now, in this quadrant, if we would write down the ratio for sine, it would still be 3 over 5. It's positive. But the cos theta would be -4 over 5. And for tan theta, it would be 3 over -4, giving us a negative value. So you can clearly see that only the sine theta is positive in this quadrant. That's why, again, it lines up with the S over there. Now in the third quadrant, if we look at our triangle, if we draw another triangle, and you will see we're going to work with the angle, and our angle is still theta, 180 plus theta, as you can see. The x distance, the coordinate for the x will still be -4, but now from the second to the third quadrant is being reflected around the x-axis, so this will become a -3. The radius is still a positive number and will be for the rest of this example and for any other scenario. So let's look at sine theta in this quadrant. -3 over 5, it's a negative. Cos would be -4 over 5, it's still a negative. And tan would be -3 over -4, which makes it a positive because the two negatives cancel out to become a positive. So you can see in the third quadrant that tan is the only one that will be positive. Now the fourth quadrant, let's draw our triangle. And remember, we're working with 360 minus theta in the fourth quadrant. The 4 units for the x is still there. For the y value from the first to the fourth quadrant is again a reflection around the x-axis, which makes this -3. And the radius will be 5. Okay, sine theta in the fourth quadrant. negative 3 over 5. Cos theta is 4 over 5. And tan theta, negative 3 over 4. So the only one positive in this quadrant is cos. And there you can clearly see, excuse me, it lines up with the cast diagram. Now let's again just look at the values, and you can see it works out perfectly. So for sine, 3 over 5, 3 over 5, negative 3 over 5, negative 3 over 5. So can you see it's only the signs that changes. For cos, 4 over 5, negative 4 over 5, negative 4 over 5, 4 over 5. It's positive. Tan, 3 over 4, negative 3 over 4, 3 over 4, negative 3 over 4. So this is just another way of looking at the cast diagram and helping you understand it.